Hello, this is Mrs. Poland. This is Unit 3, Lesson 2, and the third video. I wanted to go over the homework, and we are going to, let me get a pen out. We're going to go over question 1. Which of the following characteristics does not pertain to the graph shown at the right? Well, we notice that the end behavior shows that as you are going to the left, the function is decreasing, so it's going down. And as you are going to the right, the function is increasing. So let's take a look at the choices. So this is correct. So the first option is correct. And the second option is correct. We have 3 real zeros, so that's correct. And let's look at that last choice, increasing across the positive x-axis. Let me get rid of this. So what that means is you're only looking at the positive x-axis, so that's everything to the right of the origin. And notice that the function is, let me get another pen out. It's first decreasing and then it's increasing. So therefore, it's not increasing entirely over the interval, and that's why this is the incorrect choice. Or rather, this is the full statement, which is the correct choice. Example 2. Which of the following characteristics does not pertain to the graph shown at the right? Well, we see that this is an even degree because both ends are going up. So that means as x approaches negative infinity to the left, f of x is approaching infinity, it's going up. And as x approaches positive infinity, that means you're going to the right. F of x is also going up, it's approaching infinity. So we know this is a true statement. We see that we have a repeated 0 at 0. We can tell because you see there it's bouncing or kissing the x-axis, so that's a true statement. We have 1. Whoop, let me get that pen out. We have a root here. We have 2 roots here, right? It's a repeated root. And we have a regular root here, so 1, 2, 3, 4. So that's a true statement. And we could see that this is the only choice left over, and we don't really have a whole lot of information, but we don't see a multiplicity everywhere, just at 0. The third question. Find the zeros for the following polynomial. So x squared, we have a 0 at 0, and that has a multiplicity of 2. Now let's take the second factor. We have a 0 at 3 with a multiplicity of 2. And here we have a 0 at negative 1. With a multiplicity of 1 because there's no exponent showing, so we assume 1. Here we have a 0 at negative 4 with a multiplicity of 3. And so that is choice 1. Problem number 4. Assuming only real zeros, what is the degree of the function shown above? Well, we see at negative 2, it's bouncing, so it has to have at least 2 roots, or 2, 4, something on that order. Here it's passing through, so that means at negative 1, so there's 1 root here. Here it's passing through, so we have 1 root here. And at 2, it has a bounce or a kiss, so there are 2 roots here. So if we add up all the multiplicities, we have 3 plus 1 plus 2, which is 6. So it has a degree of 6. The M behavior, you see that it's going down to the left and down to the right. So that is choice C. And let's go on to the next question. Which of the following equations at the right, when graphed, will intersect the x-axis only once? Explain how you arrived at your answer. So what we want to do with these is we want to factor them. So we're going to take 2x cubed minus 16x squared plus 32x and set it equal to 0. We see we have a GCF of 2x. And I could factor that further. So I have 1 0 at 0 with a multiplicity of 1. And here I have a 0 at 4 with a multiplicity of 2. So we have a total of 3 roots. Again, here it's going to actually kiss the x-axis, and here it's going to pass through. So therefore, this can't be the answer because it's saying only once, and I have actually 3 times. Okay, so now let's examine this second equation. We set it equal to 0, and I have 4 terms, so we're going to be grouping. I have a big GCF of x minus 2, so I divide that out. So I set each factor equal to 0. So 1 0 is 2, and its multiplicity is 1. And the other, x squared can equal to negative 4 under the real numbers system, so there's no real 0 here. So that means I have only 1 0, so that's the answer, choice B. But let's examine the third one anyhow, just to see what it looks like. So here's the third equation, and again I have 4 terms, so most likely it's grouping. Here I'm going to factor out a negative 1. Remember, for that second term, you don't want to have a negative in front of it. Notice that both parentheses now contain the same thing. It's actually a negative 1 that you factored out. The x squared minus 1 can be factored further using dots. Told you everything's all about that factoring. So if you need to work on that factoring, make sure you do so. Notice I have 3 zeros, all with a multiplicity of 1. And so therefore, that's just confirms that C is not the answer. For example or homework problem 6, the first thing I want you to do is find the y-intercept. The y-intercept you find by setting x equal to 0. Again, it's where the function crosses the y-axis, and that occurs when x is equal to 0, so that's why you set x equal to 0. And so in this case, the y-intercept is negative 3. The end behavior of the function, you look at each of the variables in the first portion of the parenthesis and you get 2x cubed. That means you have a third degree. Your leading coefficient is positive. Therefore, the graph is going to fall to the left and rise to the right. More formally, as x approaches negative infinity, as you go to the left, your y values, f of x, is going down to negative infinity. As x approaches positive infinity, in other words, as you go to the right, f of x is approaching positive infinity. You're going up. For part C and D, you actually can just plug the function into the calculator, or you could do it by hand. I'm going to do it by hand. So let me get that pen out. So you're going to take 2x plus 1, and you're going to set it equal to 0 and solve. So you have a 0 at negative 1/2. It has a multiplicity of 1. You have a 0 of 3 with multiplicity of 1. You have a 0 at negative 1 with multiplicity of 1. And so what I'm going to do is I'm going to graph those three roots. And let's see, on the y-axis, it's negative 3, and that's positive 3. And so we have, again, a root at negative 1/2, negative 1, and 3. And we know that it just passes through each, and the end behavior was this. So the function will look like this. So for part C, you're looking to find the values of x for which f of x is greater than 0, meaning what x values are shown where y is greater than 0. That means your values of y are above the x-axis. And we can see that occurs between negative 1 and negative 1/2. And it's also occurring for values of x that are greater than 3. Part D says, how many relative maximas does this function have? Well, we could see we only have one between negative 1 and negative 1/2 right here. This value is actually a relative minima.